This is a video that's long overdue. It's time to look at the real problem with weather modification and geoengineering, ladies and gentlemen. And the issue is a lot of us don't know what it is in particular that we're looking for. And on top of that, what is utilized to execute such operations that are weather modifications. So I see everywhere throughout the sphere between discourse of meteorology, the commoner, if you will, that is interested in this topic, missing the target on what some of these things can do. And this video is going to take a look at the direct energy weapons that are lasers that are incorporated into our synoptic setup, and we're going to go over a blatant case of this. And because I'm the only one doing this, the first one to the game doing it, it's all the proof that I need that nobody out there, minus the ones that are executing this and the ones that implemented this technology, are aware that this is going on. And I'm not speaking for all meteorologists, I'm not speaking for all of that community that's aware of this, that has decided to be quiet about it, because maybe there are some out there that do see this, but they don't know how to go about addressing this. So we're going to go ahead and talk about this, and we're looking back on July 30th of 2025. We're looking at simple water vapor imagery loop, and I want us to look at the Northwest. This is going to be really the sole focus of this video. I'll touch up on some of the thunderstorms that are occurring across Iowa, Minnesota, and Wisconsin, but this is where we're going to be looking for our direct energy weapons. And the hint I want to give you is look at the whole cloud structure, all of the clouds across Oregon, Washington, that's Nevada there, in Idaho, Northern California. This is a tiger that is growling, and you will see that its paw is up in Montana. And you have to play it as an animated loop in which this is doing so, but it is an angry growling tiger sticking its tongue out, and it has its paw out up in Montana. We're going to go through and look at this, and this is kind of the side profile I want us to take a look at with this, or keep in mind as I roll through on the frames with this, is that tiger with its ears drawn back, angry looking. It's sticking its tongue out and it's growling. So when we put this side to side, this is generally what we are looking at for the desired imagery we're trying to get. Now, here is the frame by frame on it, and I want us to note across all of the cloud features, it's within the cloud tops and the areas where we have a lack of cloud, which is the blacks here. Anywhere where we have whites or really dark whites, those are really high level clouds on this overlay. But I want us to note, look at how the cloud level tops themselves are what make the texture here for this growling tiger. And that's going to be important towards the end, because I'm going to pull up a sounding and we can see in fact that yes, this environment reflects the ability to execute such an image. So it's important to remember that when we look at this and the whole nature of the direct energy weapons, we have to have an environment present that can support it. And when I say that, we have to have available moisture, which are our clouds, and we have to have a synoptic setup or synoptic ingredients that are there that we can see that a direct energy weapon laser can burn through what's available. So what I'm trying to say here is we can't just do this out of nowhere. Now, certainly the tech that's involved with this, is, as it is low Earth orbit satellites, those are always there up above your head. And there's over 10,000 satellites that circle our heads, ladies and gentlemen. Now, out of those 10,000 satellites, the ones that are equipped with the phased array antennas that are zapping the numbers and imagery, I don't know that number, but we do know that these are above your head. They're there 24/7 simultaneously. They're in low Earth orbit, and they complete a revolution around the Earth in about 90 minutes. Now, that depends obviously on the altitude of this satellite, but by and large, these satellites complete an Earth orbit in about 90 minutes. That's a speed of roughly about 17,000 miles per hour. And we have altitudes in which these sit anywhere from about 120 to about 1,200 miles, or 160 to 2,000 kilometers. So that gives you a little bit of a sample size to deal with in terms of the speed and how high these are above your head. So let's go ahead and go through frame by frame on this, and note the texture of the clouds, especially up in Idaho and in central Washington towards Seattle. These are what make the ears on the structure, and its eyes are sitting right in towards southeastern Oregon and southern Idaho. We can see the nose is down towards north central Nevada, with the tongue sticking out right towards Reno. And on top of that, there are numbers that are zapped within this. We can see 26s. Some of the striping I've denoted here on the side of the head. We can see COM25, COM25. I've picked out we have 76 COM25 in here, but we can clearly see that this is calculated, it's timed, and it is properly executed to the point that we get beautiful imagery on this. This is really one of the more crafty, if not the most skilled and timed out depiction I have seen them do. And again, this is back on July 30th of 2025. Took some time to really go through this and trace this out, because I wanted to make sure we get the definition correct on this. We can see the outline, the shadowing here of the eyes. This is really the outline of both of the eyes right in through here. And this is a cat paw, and I want us to imagine this cat is angry. It's got its paw out and it's screaming here. It's growling. So a pretty remarkable image for what it's worth that this is executed. And here's the sharpness. Turned it up for us. We can see the 26 double 26s here across Missouri, or excuse me, that's Montana, not Missouri, across Montana here. And the striping, I tried to put the negatives in orange with the positives in white, and the tongue is draped down there across California. Now, let me, before I get ahead of myself again, here's a look at just one coloring. We sift from multiple just into one. So we can see again, this is in fact the overlay of this angry tiger here. There's the 26s. And let's get into a little bit of how this is going to be executed. And I want us to imagine this circle I've drawn out is the rough digital lens space of that satellite. So anywhere within that circle, that's where that digital board is. And keep in mind, it has to go within, let's say for the sake of this example, the arbitrary area that this satellite is running on Earth orbit is in this strip. So it'll always stay in this area. It'll always go over the same spot every 90 minutes. It's just a matter of when do you turn this infrared or thermal sensor on with this digital phased array board and zap the 26 through there. So that's what they're doing with this. I'm trying to show you that at some point the satellite, and what I don't know is, again, this is arbitrary, that just the zone I've depicted. It can be anywhere along any trajectory within this 26. I'm just drawing one specific point and saying, let's say for the sake of argument, that this satellite goes over this fixed location. So we can expect to see then at any point in time, let's say maybe a couple minutes prior to the 26 being zapped here, this is where the satellite's digital space was. And then with time, you know, it moves along this trajectory here. Or in other words, we can say the center of this moves along this X, this point here. And then at exactly 8 o'clock or just prior to that, that's when that 26 was zapped through these clouds. And then it shows up as that desired image there, hence the couple of 26s. Now, we can see that some of these are larger and some of these are smaller. Now let's go into the case of perhaps a smaller one going on another arbitrary projection or trajectory. Let's say this one's going in low Earth orbit across this plane. Then we can get that desired numbers zapped maybe across the ear, right, in this specific location at exactly 8Z at the time they have this desired image. And what you guys can see is as we paint this picture with this, that's how we get our image desired. It's okay, it's a network of all of these that move with time. And I even showed you through here. Let's say this is, we want to zap a 2 up here across Canada and Washington. It would have to stay confined to the rules of within this circle here, because that's where that digital phased array board is that's reflected on the top of the clouds as this is sitting up there in orbit. So now let's get into what's going on during this time and how this was executed. Is even possible to do this? Is what we're seeing up there really there? And I promise you it is. This is a surface map. Here's high pressure. Have a couple areas of low pressure through here. I should really draw this in red, but for the sake of simplicity, we're going to keep this all in blue here. So weak low across Washington and Oregon, and that tells you that there's going to be some precipitation. There's weak forcing here, not a whole lot of mechanisms that are going to give us heavy precip, as the heavier precip's off towards the plains. It's in Iowa this particular day. There was a severe weather outbreak happening in this area across the Central Plains, but you can see this is the cold front. The cold front's right along in here. We have another high sitting across the southeast. This high pumps up that moisture and the heat, and then voila, we're going to have thunderstorms across the central U.S. And it's only fitting we have a growling tiger while this is happening, precipitation-wise, because I went ahead and saved this on loop. And we can, in fact, see in throughout the evening and into the overnight that, yes, there was a severe weather outbreak. A strong line of severe storms did rip through the eastern Dakotas, Nebraska, through Iowa. So it's only fitting we have a roaring tiger off towards the Pacific Northwest that is looking at this menacing complex of thunderstorms as it's breaking out, as it's developing. Now, again, that face is off towards the northwest. There's not much going on in this area. Surely there are a couple of some thunderstorms that erupt in through southern Oregon, but that's it. Once we lose the daytime heating and instability, that runs itself out. The thunderstorms run out of that juice, and the main show is that severe weather complex off in towards the north central plains and north central U.S. Boise, and we can see this checks off the list. I want us to note, whoops, let me go ahead and go back here. I want us to note, let me get my annotations out. If we don't have any low-level moisture, we want these two lines to be closer next to each other to signify greater levels of moisture. This is our dew point temperature, TD. This is our air temperature. And this is in Celsius down through here. So it's warm, guys. We're talking upper 20 Celsius in summer. This is a summertime pattern up in the Pacific Northwest. It's nothing out of the ordinary. I want to stress that. It's nothing out of the ordinary. It's just simply noting that we're taking these synoptic inputs, and with those synoptic ingredients, we were able to execute that tiger. Now, where is the moisture? The moisture is aloft. It's all aloft. And when I say aloft, it's at 500 millibars. We got to go all the way up to this point to see where our temperature, our dew point temperature, and our air temperature are near fully saturated. This is where we see our clouds develop, and that's what we see on our loop. These are mid to upper level cumulus clouds in this area. So the sounding checks out with this. I'm not showing anything out of the ordinary that's strange, and we can even look at the point here that there's no instability anymore. That's CAPE. CAPE is our instability. Now, at the surface, there's no instability, so we're not going to get any precipitation. We're not going to get any thunderstorms. There is actually a little bit of some elevated instability up through here, but we don't have a forcing mechanism or that oomph to draw these storms or to kickstart any thunderstorm. So what we get, guys, when I rolled back on that radar was a couple of scattered thunderstorms early in the evening across southern Oregon. And then after that, it dissipates. We run out of our instability, the limited instability that's there, and it just dissipates. So I'm pointing out that, yes, we can execute an image with this. It's taking a look at those airfields where we can put localized dry air to get localized circulation. And then it's knowing where we have our specific satellites that are in low Earth orbit above our head that are executed at a given time frame to get our desired image, which in this case was a roaring tiger looking off at the menacing storms that ripped through the Central Plains on the evening into the early morning hours on July 30th. Guys, this is what we have to take a look at when we're looking for direct energy weapons. They're sitting right above your head. They are incorporated every day into the synoptic setup. It's up to you guys to be aware of it and know what's going on with these. They have minor impacts on our weather. Don't give them that much of the benefit of the doubt. This isn't completely geoengineering weather. This isn't creating things out of nothing. I always want to stress this, and I can't stress it enough. It's taking our current atmospheric inputs and working some magic with it. Thank you for watching this, guys. I hope this is comprehensive and understanding for you all. And as always, I hope you take care.